Hello, my dear students. Welcome back to my YouTube channel. I guess I'm audible and visible to all of you. Let me just give you a comments if I'm audible and visible to all of you. Am I audible? Am I audible? That's great. 1 second. Okay. Okay. I don't think no that we're having any kind of lag today, right? I guess today we don't have any kind of lag, no? But there is some sort of issue with my device. It is just stucking. Let me check it once. No, it's done. So let's start now. Okay, done with that. Got it. So let's continue our session. Okay, I guess today we are just dealing with the self-induction. I guess my screen is visible to you now. Okay, so if you have watched the yesterday's class, so you might know that yesterday the last topic that we done that was a self-induction. It is a process in which a coil is giving opposition to the main current for a micro or milliseconds, right? Until there is a fluctuation in the main current. Okay, so let's continue our lecture from this particular slide. So yesterday we concluded that L is equals to, it is phi divided by I. L is coefficient of self-induction, phi is flux, I is current. And the thing that you need to remember that L is independent. L is independent on flux and current. Okay, my flux, it doesn't depends on these two parameters, phi and current. But you can just tell me that, sir, but we are having an equation which just clearly states that our induction coefficient is phi by I. But my answer is, we know that force is equals to mass into acceleration. So we can write mass is equals to force by acceleration. And mass is a simpler quantity, you know? Mass is not depending on force, is it not depending on acceleration. One more example. An example is, we know that by Ohm's law, V equals to IR. So my R came out to be, it is V by I. And we also know that my resistance is not dependent on voltage, neither on the current. If we have noticed one more equation, that is Q equals to CV from capacitor chapter. So capacitance came out to be Q by C. It is not depending on charge, it is not depending on the potential difference. So in the same way here, my L is independent on flux and current, but it do depends on shape. Shape means length, radius of your coils. Then radius, or you can write area. Then you can write medium that is filled inside this coil. Then easy beta, easy or super easy. Now if you need to derive, it is unit, the unit of L. So you can write L equals to phi by I. The unit for flux is Weber, unit for current is ampere. It is Weber per ampere, which is also known as Henry. Okay, so the unit for coefficient of self-induction is, it is Henry only. It is Henry, right? Just remember it. It is Henry. Now, one typical thing that you need to remember, no? So dimensional formula. How to write the dimensional formula of my L? Dimensional formula of my L. So if you need to write the dimensional formula of L, it is dimensional formula is equals to the dimensional formula of flux to dimensional formula of current. Dimensional formula of current, it is easy now, it is A only. Yes, sir. But what is the dimensional formula of flux? What is flux? I guess flux is BA cos theta. Okay. No unit for cos theta. Trigonometric ratios, they doesn't have any kind of dimensional formula. But flux equals to dimensional formula B and A. A is area, area means L square. What about the B? What about the B? How to find the dimensional formula of B? We know one thing now, sir. What do we know? Force F equals to QVB sine theta. Same, no dimensional formula for sine theta. So I can write B came out to be F by QV. F is force, which is MLT minus 2. Q is charge, charge means AT, current into time. V is velocity, LT minus 1. So can I write here, it is equals to MLT minus 2 divided by AT, divided by LT minus 1. Just change it now. This T cancel out. This L cancel out. So what do I have now? I can have a M L2T minus 2 M L2T minus 2, that is A minus 1. Now flux came out to be, it is ML2T minus 2 A minus 1 whole divided by, it is A only, right? Now this A got upside, so I can write L is equals to, it is ML2T minus 2 A minus 2. Dimensional formula of L. Easy? Easy or super easy? This is how you need to manipulate these things, no? So by the simple numerical, we concluded that what is the dimensional formula of B, magnetic field, dimensional formula of magnetic flux, dimensional formula of coefficient of induction, by simple numerical. Okay. Look beta, if suppose we are having a coil, this particular thing represents a coil, and in this coil my current I is passing. So we know that this face is north and this one is south. And if this current is increasing, so we know that's my main current. This is I. Is this main current? Yes, sir, it is main current. Main current is going from north to south, or it is going from left to right. So, and if it is increasing, so in that particular scenario, according to Lenz's law, there will be an induced EMF which is opposite to it. So I can write the induced current. Induced current will be induced current, no? I induced. So induced current is opposite to of the main current. So the induced current is going from right to left. Can I write it is battery positive one, negative one? That's why you can say that, sir, the current is going from left to right. So right to left. Okay. But what is main current? I guess main current I is going through this one, no? Now main current is going into this particular arrangement. So we know that if current is going towards the positive side, it is charging. From current, we know that it is charging process. Look now how you can just merge these concepts. Electricity, electric current basically. Magnetic effect, here we are having EMI. How we are just collectively having these kinds of things, right? Okay. What we know that? We know that, sir, flux phi is equals to L into I. We know this thing now. And what is E? Sir, E, induced EMF it will be the opposite of d phi by dt. Phi simply increase in, it is basically of Lenz's law. Okay, E equals to minus d by dt. What is phi? Phi is Li. L is constant, no? Can I write E equals to minus L di by dt? So what is E here? E means induced EMF. It is induced EMF. What is L? Coefficient of induction, self-induction. I can write self-induction here. What is di by dt? Rate of change of current. Rate of change of current. Done? Clear, no? Easy? So we are having the equation now. E equals to minus L di by dt. E equals to minus L di by dt. Done? Okay. Okay. Look now. What is now? Do you know if this is the core of my material, and we are having a something like this, no? Wire is wounded on this particular material. Current is going I and current is leaving I. We know that this will become now, sorry, North Pole and this is the South Pole. We know it, no? My magnetic field will be in this way. And I guess area vector is same as this way. Okay. So what is flux? Sir, flux is equals to BA cos theta. So flux, I can write it as a BA cos 0 degree. Cos 0 is 1. So flux came out to be B into A. Done. If it is a solenoid, and if it is a solenoid, for solenoid, B equals to nu naught Ni, or B equals to nu naught capital Ni by L. Okay, I guess we know these things now. So what is flux now? Okay, what is flux now? I guess I can write now flux. Flux is B into A. It is B into A. So I can write flux now B. What is B? B is nu naught Ni into A. Or I can write it as a nu naught Ni by L into A. Done? Clear now? So what is L now? What is L now? Sir, L equals to phi by I. So is it equals to nu naught Nia by I? Or here I can write nu naught. It is nu naught Nia by L into I cancel out, I cancel out. Either I can write L came out to be nu naught Na. Here nu naught Na by L. These two equations. But this is for single turn, right? If let us suppose we are having n turns. If it is for one turn, no? If let us suppose we are having n turns. We are having n turns. If we are having n turns. N turns. So what I can write now? I guess L equals to single one. What is single one now? It is N multiplied by the for one only. It is nu naught NaL. L. So I can write it as a nu naught N square A by L. I guess I can write it like this now. Okay, can I multiply it with L, divide it with L? Yes, sir. I can write nu naught N square. It is AL divided by L square. What is AL? AL is volume. So I can write it as a nu naught N square into volume, right? And divide by L square. We know that small n, number of turns per unit length. So if I just squaring these things now, I need to write N square. So this equation I can write nu naught N square into V. nu naught n square into V. I can write like now. So how many formula we are having now? Look here. One formula, this formula, second, right? Done. So what we can write now? I can write that nu naught n square a by L, one formula. I can write n times nu naught n a. So look, this formula I cannot write it now. So because we have written it already, so I can write now this one formula. Then now this one nu naught n square a into L. I can write like this also, right? So you need to remember these formulas, na? You need to remember these formulas. So why we need to remember these? Look now, I will just show you the question now. One second. Okay, this numerical. One second. Okay. So we are having a numerical this one now. Okay. Just read this numerical. Okay. Numerical is a current of 2.5 ampere flow through a inductance of 5 Henry. The magnetic flux linked with the coil. So what we need to find out? Magnetic flux. Phi. Phi equals to L into I guess. Phi. What is L? L is 5, right? I is 2.5. 5, 5, 25, 2. 5, 2, 10, 12. I guess it is 12.5 Weber. B1. Easy? Easy or super easy? Huh? Easy or super easy? Okay, now this one. Second numerical. Second numerical like a long solenoid of 500 turns. So what we are having now? N number. N came out to be 500. Okay, now second point. Current is 2 ampere. Current means I. I came out to be 2 ampere. Then is passing through it. The resulting magnetic flux. So what I need to find out? Flux. Magnetic flux with each turn. And look, I guess the flux is given, no? Flux is given, flux is given, flux is given. So flux is given this much. So what we have to find out? Self-inductance. So I guess L we need to find out. L came out to be phi by I. Is phi given to us? Yes, sir, phi is given to us. But look here. It is flux of one coil. So I need to just multiply it the number of turns. So what is N? N is 500. What is phi? Phi is 4 into 10 to the power minus 3 divided by current is 2. 2 ones are 2, 2 twos are 4, 5 twos are 10. So we are having 10. 1, 2, 3 multiplied by 10 to the power minus 3. I can write it 10 to the power 3 minus 3, 3, 0. That is 1 only answer. So I guess my answer is 1 Henry only. Easy or super easy? Easy or super easy? Now, next numerical. Okay, this one. Is this one easy now? Yes. Question is, if the number of turns per, no, look, what is given now? Number of turns per unit length. That means N is given, N. Of a solenoid is doubled. If we double the N, the self-inductance of the solenoid will be. Okay. So how we can just proceed in this numerical? What is L? Sir, I guess L equals to nu naught N square AL. It is constant. L is constant. A is constant. So L is proportional to the L square. If you doubled, so that means I can write it is 2 square. It came out to be 4, no? So I guess become 4 times. Easy or super easy? Easy or super easy? Huh? I hope it is super easy, no? Let us do this one now. This one now. Okay, this one now. So what is given to us? The solenoid have a cell of inductance 2 Henry. That means L is given as 2 Henry. Okay. If the length of this solenoid is doubled, that means initially is L, then we are having 2L. Done. And having turns, having turn density. Turn density means and area. And an area is constant. And an area is constant. How we can proceed now? What is L? Is it nu naught n square Al? Constant, right? Constant. Area constant. That means inductance is proportional to the length. Done. Inductance is proportional to the length. Srinidhi beta, I am not, look. I am working somewhere now. Here I am just giving my extra time, extra effort to my students, right? I am working somewhere now. I am not some sort of, not working somewhere, right? Sir, previous one again. Which one beta? This one? I am working somewhere now. Don't worry about me. Okay? This is my extra time that I am giving to you. Don't worry about it. Okay? No worries, no? This one? Hasana beta, this one? Before this one. Okay. This one? राघव JOD हिंदी में भी कुछ बोला करो तब ही तो व्यूअर्स आएंगे सर लेकिन आप ओनली स्पीक इंग्लिश बेटा बेसिकली लुक ना so I am teaching somewhere, right? And I just connected with my students, so they're having some problems with their physics. So based on the request of my old students, right? And my maximum students came from the English background, that means from South India. Okay, so I just started these kinds of classes, na? That's why. But I'm just thinking that in future I will launch courses. Don't worry about it. I will launch courses also, right? In coming days, I'm just having my 11th portion also completed. In winters, I will be completing the syllabus for NEET also, right? Fast track series. Don't worry about it. You will get a lot of things from my end, right? Look now. What is given to us? What is given to us? You can see from this particular slide, long solenoid of 500 turners. N is given to us. Look, if only one turn is there, so you can simply write N L equals to 5 by I, no? But how many turns we are having? 500. So flux is associated with 500 turns, no? We are not, look now, for one particular flux, for one particular coil, N is 1. But it is given here that we are having 500 turns, right? So I guess the flux would be now 500 times flux of 1 divided by I. 500. What is flux of 1? Sir, it is given this much. Now I can write 4 10 to power minus 3 divided by current is 2. 2 ones are 2, 2 twos are 4. So I can write 500 multiplied by 2 into 10 to power minus 3. 500 2 minus 1000. 1000 means 10 to power 3, 10 to power minus 3. Cancel out, answer is 1. So answer is 1 Henry only. Okay, now I guess we are doing some numerical. Okay, this one now. Okay, so basically L is proportional to the L. Done. Now, initially, my length was L, okay, and the L was 2 Henry. Now we just doubled the L, it is 2L. So can I write now? Initially it was L, okay. So I can write initially if there is L, so we are having 2 Henry. Now we are having 2L, so I can write 2 into 1 Henry. This one, it is 2. So 2 to the 4, it is 4 Henry now. 4 Henry now. I am giving you the good content, no? You can just see the numericals, right? The varieties of numericals that I am giving to you. So just utilize these things in a very good manner. So I guess these numericals is done. This one is done. 4 Henry. Okay, this one now. So you can see now this numerical is from, I guess it is JEE means 2019, right? Okay. How we need to proceed in these numericals, right? Look, what is given to us. It is very easy to you now. The total number of turners. Total number of turners simply indicates it is what? Is it N? Yes. And cross-sectional area in a solenoid is fixed. That means this capital N and area A is fixed. However, its length L is varied by adjusting the separation between the windings. That simply indicates my L is not fixed. The inductance of the solenoid will be proportional to. Sir, we are having two formulas. You can see now. You can see upwards we are having two formulas. Look here, right? So one formula is nu naught n square A by L. Second one is nu naught n square AL. So you can see, sir, n is given. If n is given, so we cannot use this formula. No, we will use this formula. We will use this formula. So which formula we have to use now? Sir, my formula is L equals to nu naught n square A by L. This is constant, constant, constant. So L is proportional to the 1 by L length. So I guess option number A. Option number A is correct. Option number A is correct now. Done? One more now. Okay, this one now. So you will see now varieties of numericals in the class. Varieties of numericals. Look now. So what is given to us? What is self-inductance of coil which produces 5 volt? That means EMF. E is given to us. Okay. When current changes from 3 ampere to 2 ampere. So current changes from 3 to 2. That means initial current. I initial is 3 ampere and I final is 2 ampere. What is DI? What is change in current? Is it final current minus initial current? Yes, sir. Final is 2, initial is 3. I guess it is minus 1. In 1 millisecond. So my time is also given 1 millisecond. Now 1 millisecond simply indicates 1 10 to power minus 3. So we have to find out self-inductance. Sir, what is the formula for self-inductance? We have a couple of formulas now. Nu naught n square AL, nu naught n square by L, that is A, right? So, but we have one more formula, E equals to minus L di by dt. E is given as how much? 5 volt. Minus L. L is given as anything? No, L is, we have to find out L. Di is minus 1. Dt is 1 10 to power minus 3. Minus minus cancel out. So I can write L equals to 5 into 1 10 to power minus 3 divided by 1. I guess L came out to be 5 into 10 to power minus 3. L came out to be 5 millihenry. 5 millihenry. Option number B is correct. Option number B is correct. Easy or super easy? I guess I am giving the good things, right? Look, we completed the topic very well. Sir, how you are telling us that we have completed the topic very well? If you are getting this numerical, now that means your topic is good. If you are getting stuck by somewhere, now you need to repeat this topic then. Okay, I guess until now we had done everything, no? Okay, next numerical. This numerical is basically a combination of very numericals. So one is this one now. Okay, this one now. Okay, what you can see from this numerical, what is given to us? Sir, you can see now the current I in a coil varies with time. That means we don't have a constant current. Current is variable. Okay, sir. The variation of induced EMF with time would be. So we need to find out. Look, IT curve is given. We need to find out ET curve. So how we can find it? What is E basically? E equals to minus L di by dt. Look, current, it is I into T curve, right? So what is it? Is slope. So slope of this curve will be di by dt. So it is E equals to minus L into slope. Done. Look, if we are going from 0 to this particular point, 0 to let's go A point, this is theta now. So you can see that theta is less than 90 degree. So tan theta is less than 90 degree. So you can write tan theta came out to be positive. So you can write my slope is positive. If your slope is positive, you will write di by dt is positive. Look, now first one now. First from 0 to A, my tan theta is positive and it is constant now. Slope is constant, right? So I can write it like, sir, it is constant, but it is, look, negative into positive. It is positive now. So you can write E equals to minus into plus. Minus plus is minus. So you can write it, it is coming from this side. It is 0 and it is A. Now this particular side, this one now, from A to B. A to B slope is 0. Slope is 0, so E equals to minus L into 0. E came out to be 0. E is 0, so my E is 0. Done? This one now, you can see now, my theta is more than 90. Theta more than 90, M equals to negative. So my E came out to be negative into negative, that is positive. So it came out to be like this. So option, this one is correct. This one option is correct, no? Done? Easy or super easy? Easy or super easy? Huh? Easy, no? Okay. One more numerical. Now we will be doing some different types of numericals. Different one now. A different one. So different one means this one. So I guess you know now the point potential method. You know now the point potential method. Yes, sir, from current electricity. The same we used in our capacitor. So what is given to us? A part of complete circuit is shown in the figure. At some instant, the value of current I is 1 ampere. So I is 1 ampere. Done. And it is decreasing. My current is decreasing. Rate is given to this, no? So that means my current I is equal to 1 ampere. Di by dt, it is given decreasing. Decreasing means minus, and it is 10 to power 2. Done. So we have to find out Vp minus Vq. Look here. Current is going in the direction. Okay. Potential here is Vp. So I can write Vp. Now we are going in the direction of current. So I can write here potential is IR, but minus IR. Minus to positive, it is positive 30. Look, whenever we are just entering this inductor, direction of current, it is minus L di by dt. Equals to V, it is Vq, it is Vp. So Vq we don't know. Vq we don't know. But what we know, it is I. What is I? I is 1. R is 2. Plus 30 minus L. L is given to us, no? Yes, it is 50 millihenry. 50 millihenry. Done. Di by dt is minus 10 to power 2 equals to Vp. Look, Vq came out to be, it is minus 2 plus 30 plus 10 to power 2, 1, 3, it is 5 only, equals to Vp. Vp, right? So can I write now Vp minus Vq equals to 35 minus 2, it came out to be 33 volt. 33 volt. It is 33 volts. Done? Easy, na? Look, we are combining many things. And it is easy, right? If you had watched my series of current electricity, then it is very this much of easy to you. Okay, next numerical. Next numerical. Enjoy the process, na? Enjoy the whole process, right? Okay, let us do this one numerical. This one now. This one now, right? So in the same way, now we're having different one, right? So here my current is a function of time, 10t plus 5. Okay. At t equals to 0, the potential difference. That means when t equals to 0, I need to find delta V. Okay, so current is equals to 10t plus 5. So what is di by dt? Di by dt is only 10 plus 0, which is 10 only. And what is current now? Current now, no. Current when t equals to 0, it is 10 into 0 plus 5, it is 5 ampere only. It is 5 only. Done. So now let us go from this much. I can write potential at P minus I. I is 5 into R. R is 3. This minus L di by dt. Then plus 10 equals to VB. So VA, it is VA. Now it is VA minus 15 minus L. What is L? L is 1 Henry. Di by dt is 10 plus 10 equals to VB. 10 cancel out. So VA minus VB equals to plus 15 volt. Plus 15 volt. Easy, super easy. I need the answer from your end now. Is this easy or super easy? Huh? Easy or super easy? Okay. Now we are having a topic that is energy stored in capacitor. Next topic is energy stored in capacitor. Oh, it is not capacitor, no, it is inductor, right? Inductor. Sorry, it is inductor. Done. So if we are having an inductor like this, current I is flowing, okay, and this current is changing. It is changing and increasing. I guess we are having a current which is opposite to it, and this current is induced current. Okay, it is main current. To get my main current unaffected, my battery is doing work. My battery is doing work, and that work is getting stored inside the inductor in the field of magnetic field. Okay, and this energy is potential energy U, which is 1 by 2 Li square. How, sir? Because we know that in my capacitor, my energy U equals to 1 by 2 CV square. There we derive it, no? So here I cannot derive it, no? There we have a topic now, energy density. In my capacitor, we are having a energy density. Do you know the formula for energy density? Any formula for energy density? Yes, it was 1 by 2 epsilon naught E square. So here we are having B, no? B naught. It is 1 by 2 B square by nu naught. So their energy is stored in an electric form. Electric field, right? Here energy is saved as a magnetic field. Just remember these things, no? These are very easy things that you need to remember. Very easy things, right? One more numerical. Okay, one thing. This much now. Okay, this numerical now. This one now. The magnetic potential energy stored in a certain inductor is 25 millijoule. That means U is given to us 25 millijoule. Done. When the current is in the inductor is 60 milliampere, when the current I is 60 milliampere, inductance we need to find out. Okay, U equals to 1 by 2 Li square. So L came out to be 2U divided by I square. 2. What is U? U is 25 10 to power minus 3. I is 60 10 to power minus 3. 60 10 to power minus 3. Cancel out. So it is 50. 50 divided by 36 10 to power 2 minus 3. It is 50 divided by 36 10 to power minus 1. So it is 500 divided by 36. So it would be somehow 13.89. Done? Easy? Okay. So now there is one more topic, no? That is RL circuit. RL circuit. But I am not going to teach you the RL circuit. Do you know why? Because this thing is not now included in your NCERT. Okay? And not important. Not important. One thing that you need to remember now, if t equals to 0, you will find two things. T equals to 0, t equals to infinite. When t equals to 0, write your thing as an open circuit. Open circuit. And infinite, it is a closed one. You know how? Open means, let us suppose we are having a circuit now. Look, we are having a circuit. Okay? If t equals to 0, make it like this much. Open. If t equals to infinite, make it like this. This much. I guess we're just, why there's an issue with it, no? One thing, beta, I'm just getting network issue from my end. 1 second. Okay, this is not important, right? This one is not important. Okay, so I guess we are done with today's session. Okay, let us continue the numerical, the session now tomorrow. So tomorrow we will have a lecture number 5. I hope you enjoyed today's session, and if you're having any doubts or if you're having anything that you want to ask with me now, so you are most welcome. What you can do now, go to the channel description part, there you will find my Telegram link. Just ping a message there, okay? Thank you, beta. Thank you, beta. Good night. Good night. Thank you. Bye. Good night. Bye. Thank you.